Parallel and perpendicular lines, lesson 2.5. So let's kind of jump into this. This is kind of an in-depth look at graphing and writing equations for lines, but just in these two scenarios. So the biggest thing that you need to understand from back in Algebra 1 is that parallel lines, the big thing you need to know is they have the same slope, all right? The exact same rise or run. So anytime they're asking you to write an equation for two lines that are parallel, make sure they have the same exact slope. And then perpendicular lines are a little bit harder. So perpendicular lines. And remember, perpendicular lines mean that they're 90 degrees to each other. So they kind of form right angles there. They form the T. Well, perpendicular lines, when you're looking at their slopes, there's two things that need to happen. Number one, they need to be opposites. All right? Meaning one has to be positive and the other one has to be negative. And then the other thing that needs to happen is they need to be reciprocals of each other. All right? They need to be flips of each other. So they have to be opposite reciprocals. So for instance, if one line is 2/3, a line that's perpendicular, remember this is a symbol for perpendicular, would be the opposite, meaning negative 3/2. All right? If you're talking about a whole number, let's say that the original line has a slope of -4. Well, if I want to be perpendicular, I need to be positive 1/4, because that's the reciprocal for 4. So they got to be opposites, one positive, one negative, and they have to be reciprocals. Now, the only weird cases for that are if you have a slope of 0, all right, that's a horizontal line, and a perpendicular line to him, you can't really do a reciprocal. You have to be undefined. So those are like the two special cases of a vertical and horizontal line. All right, well, let's get into it, and we're going to use a lot of what we did in 2.4, writing equations. So let's check out example 1 here. It says, write the equation of a line in slope-intercept form given the criteria. All right, well, what is this criteria? So we need to be parallel to this equation. So this is the original equation. So first of all, his slope is 1.5. And if I'm going to be parallel, I need to be the same. So I can start an equation. I now kind of have an idea. I'm like, oh, it's y equals 1.5x. The problem is I don't know what the b is. I don't know the b. So here's where I'm going to use the same exact skill we did in lesson 2.4. I have a point that it goes through. This xy lives on the line. It makes the equation true. So I can substitute the 4 in, and I can substitute the 5 in and solve for it. So 5 equals 1.5 times 4 plus b. This is 5 equals 6 plus b. So it looks like b's got to be -1. So now to finish the equation, I go back to my starter equation, and I'm like, all right, now I know what it is. It's y equals 1.5x minus 1. And if I were to graph these two, if I were to check them out, they both have the same slope, just one crosses at a +6, the other crosses the y-axis at -1, and everything will be good. Next example, number 2, I need to be perpendicular to that given equation, and I got to go through the certain point. So the first thing is when I see what line I have to go through, here is the slope. The slope is -3/4. Now, if I'm going to be perpendicular, I need to make a couple changes to that. So I need to make it positive, and I need to do the reciprocal. So my slope has to be 4/3. So I get my starter equation, y equals 4/3 x. I do not know the y-intercept. All right. Now, just like before, I'm going to substitute values in. So I put this -4 in for y. And then I substitute that 6 in for x. And plus b, I'm going to solve for it. So I got -4 equals 6 times 4 is 24/3. 24 divided by 3, which is 8, plus b. Minus 8 from both sides, I get b equals negative 12. So now we come back up here, and I punch in y equals 4/3 x, but now I know what b is. It is a minus 12. And again, I could now go to my graphing calculator if I wanted to, and I could verify that these two lines are perpendicular. But I can look at them and I can see that their slopes are opposite reciprocals. And then I made sure it went through the right point by plugging those values in. Number 3 just says, hey, determine if the two lines are perpendicular, parallel, or neither. Looks like I missed a comma right here. Well, let's check it out. So line number 1, there's your slope. Line number 2, there's your slope. They are reciprocals, but they are not opposites. So the answer here is no. And if I were to graph these, you know, a slope of 1/4 means up 1 over 4. I'll ignore the back part, just don't pay attention to that. But then if I have a slope of 4, that means I'm going to go up 4 over 1, and those lines are not going to be perpendicular to each other. One has to be positive, one has to be negative. All right, over here, I give you these two because a lot of times on the SAT they put them in standard form. These are not the slopes. All right, you cannot just look at those two and say, oh, the slope's -3, the slope's 9. You can't do that because it's not in the proper form. So first thing you need to do is you need to rearrange this in the proper form. Now I'm going to show you the long way, then I'm going to show you the shortcut. So let's start with this first equation. -3x plus 4y equals 15. Well, if I want to put it in slope-intercept form, I need to first move the 3x to the other side. So it's going to become positive. And then I need to divide both sides by 4, everybody. And I get this new equation. And really all I'm concerned about here is I just want to know the slope. The slope is 3 over 4. Well, look what happened. This value in front of x, you know, and remember, in general, it's ax plus by equals c. Every time you solve this equation for slope-intercept form, you're going to move that a to the other side, and it's going to be the opposite of what it was before. So notice that this -3 up here became +3 down here. And then my next move is always going to be dividing by whatever b is. So I divided by this +4. You know, I did it here, I did it here, I did it here, I did it there. That's always going to happen. So in general, it's always going to be the opposite of a over b, because you're going to move a to the other side, which makes it opposite. Then you're going to divide by whatever b is. So let me just kind of speed this up on the second one. So this person, I just found your slope. Your slope is 3/4. Well, this person, if I do the opposite of a, all right, the opposite of a, well, if this is a, the opposite of a is -9. If this is b, -12, well, a negative divided by a negative and then reduced is 3/4. So I'm like, hey, these two are the same slope. So since you guys are the same, I know that you are definitely parallel. So I checked the slopes out. They're parallel. This one over here was neither. And if they were opposite reciprocals, then I would say opposite reciprocals. Or if they were perpendicular, they'd be opposite reciprocals. All right, next one. Which graph shows a line perpendicular to 3x minus 2? So, first of all, this line has a slope of 3. I want to be perpendicular, so my slope has to be the opposite, negative, reciprocal. So I'm looking for a graph with a opposite, with a -1/3 slope. Well, this one's pretty easy because first of all, if you're a -1/3 slope, you're going down from left to right. So it can't be you, because you're increasing from left to right. Can't be you, you're increasing from left to right. This slope is going down 1 over 3. So I think that's a slope of negative 1/3. This one is actually going down 3 over 1. All right? So this one has a slope of negative 3. And we want it to be perpendicular. So the correct answer here is this one. That's opposite, but not reciprocal. All right. Now in SAT style, to wrap up this set of notes, because you do have a few of these on your homework. Which of the following equations represents a line that is parallel to the line with the equation? So they give me an equation, and I want to be parallel to that. Well, that line has a slope of negative 3. And if I'm going to be parallel to him, I also got to be negative 3. So my question is, which of these lines have a slope that's negative 3? And remember, these are all in standard form, so these are kind of nasty. So let's use that little trick that we used. Let's use the opposite A over B thing. You know, so if I work this one out, the opposite of A over B, so he has a slope of negative 3. That's what we're looking for. I think right now that's going to be the answer, but let's just double check. Opposite of A over B, well, that would be a positive 3, so you're out. Opposite of A over B, that's a slope of 2/3, not you. And then lastly, there's nothing there, so opposite of A over B, negative 1/3, it's not you. So the correct answer here is A. I think that's a really fast trick, doing the opposite A over B thing, as opposed to trying to rewrite out all that algebra, especially on the SAT, when one of the big factors is time. We want to speed up time. Hopefully that helps you out and you are ready to do the practice. See you.